Hi, I'm Sherry McCleary. I'm the Executive Director here at the Penn State Digital Foundry in New Kensington. And I'd like to welcome you back for part 2 of our 6-part series, Exploring Smart Manufacturing for Business Success. Today we'll be joined by Josh Stearman, our Senior Automation and Controls Engineer, who will be speaking to us on the topic of inputs and outputs, which is all about sensors and capturing data on your shop floor. We hope you enjoy the presentation and come back to join us next week when we talk about machine controls.
Hey everyone, my name is Josh Stearman. I am the Senior Automation and Controls Engineer here at the Digital Foundry, and today we are going to talk about inputs and outputs. Inputs and outputs, sensors and actuators, things that detect change and things that physically move, however you want to describe them, these are the base of the automation pyramid. This pyramid is something to get familiar with as it guides us through the next few weeks. Starting at the bottom, we will talk about the importance of level 0 components and where you'll see them in smart manufacturing. You'll also notice the smart factory wheel, of which sensors and actuators are involved in a few of these buzzword categories, including IoT, big data, and advanced robotics. There are sensors for detecting just about anything, such as the through beam on your garage door or the fingerprint reader on your smartphone. A sensor can be separate parts or combined into a measurement system that doesn't need an external conditioning module for the data produced. Note the flowchart on top representing a measurement system. Say we have a sensor to measure the flow rate of apple cider on a bottling line. The measure and is the flow rate that the sensor turns into an electrical signal, then must perform signal conditioning to present the signal to the external controller in a way that it can interpret. There are two common ways of presenting this signal, analog and digital, where analog allows for a range of numbers, think speedometer on your car, while digital is just on or off, think light switch. Smart sensors with this all-in-one capability are becoming much more prevalent, allowing for technologies such as edge computing, which allows for data computations to be performed at or near the sensor. IIoT devices typically take advantage of edge computing technologies. Next, we will talk about the Industrial Internet of Things, or IIoT. Think of IIoT as an expansion of traditional data collection methods, with more sensors and data, potentially including tracking on individual components that can communicate to various levels in the automation pyramid. Legacy equipment provides a great opportunity for utilizing IIoT sensing devices by means of retrofitting. A few common retrofits include power monitoring, which is essentially measuring the power consumption, current, and voltage of equipment. The benefit here is to optimize power consumption, thereby reducing costs. Vibration measurement is the next retrofitting example, which can lead to benefits in predictive maintenance to detect the wear on machines and components. Vibration frequency spectra, especially in 3 dimensions, can be complex, so computing algorithms have been developed to help sort through this data. And lastly, environmental, which includes measuring temperature, pressure, humidity, etc. In some cases, knowing ambient conditions such as these can be crucial to addressing quality issues in parts. Next, we will cover an I/O example. This slide illustrates a bunch of different sensing devices, or inputs, that are centered around the conveyor, output. Some of the industrial sensors you'll notice include common part presence and distance sensors such as the fiber optic sensor, non-contact proximity sensor, and distance laser sensor. You'll also notice vision systems, both 2D and 3D, for uses such as part inspection and part location. You'll also see a thermal imaging camera that detects hot spots on a conveyor. Lastly, you'll notice some speed encoders as well for feedback of the conveyor itself rather than detecting what is on the conveyor like the rest of the input devices or sensors. As far as the conveyor goes, there are a few variables or outputs to control, including starting and stopping, the speed of the conveyor, as well as the direction that the conveyor is going. Machine vision also falls under level 0 of the automation pyramid. Often used in automation, we have a couple examples listed here, with the first being an AI or artificial intelligence vision software that you feed a dataset of good and bad images to. It will then generate a brain to automatically detect anomalies on the parts as they pass by the camera. The second example requires some more knowledge and can be complex, but essentially uses common vision tools to detect certain criteria such as measuring part features, detecting number of features, reading part numbers, and more. These are both great ways to not only detect the part quality, but also in creating the digital fingerprint for the part being produced. I would be remiss if I did not talk a little about robotics, which fall in this level 0 of the automation pyramid. This slide shows an array of end effectors that can be equipped onto a robot. Each end effector is an output in and of itself, whether it's pneumatically or electrically actuated. It may even have multiple outputs, like in the case of the hand gripper, which has 9 drives. We have a few of these here at the Digital Foundry that we use not only in training, but also in our de-risking and prototyping projects with manufacturers. The last thing I want to mention is the topic of data, since data is central to smart manufacturing. One basic concept of smart manufacturing is to make data-driven decisions. But where does this data come from? Well, in an industrial setting, sensors are usually the answer. Now, not every sensor is going to give you valuable information, which ties into the 6 V's of data: volume, variety, and value, to name a few, which is why data engineers are tasked with sorting through and analyzing data to present the data in an easy-to-read fashion, also known as data visualization. In this, charts and graphs are helpful tools for understanding your manufacturing processes. A lot of companies are moving to the cloud to store data, and IIoT devices and sensors, which we talked about earlier, are great for this model as they can send data directly to the cloud. Now we get to enter into the Digital Learning and Demonstration Lab here at the Digital Foundry and take a look at the part sorter, which is actually a student-made capstone project from the Penn State New Kensington EMET program. Hey guys, me, Josh Stearman, down here at the part sorter. I want you guys to check this out while we're talking about inputs and outputs. First, I want to mention that this is a student-made project from the Penn State New Kensington electromechanical engineering students, their capstone senior project. Basically what it is, it's a part sorting machine, right? You put the parts in, it detects the color and the shape, and it'll shoot it into the appropriate bin. We use this as well as a legacy device, so you might notice the original sensors that are on here, such as a through beam sensor over here and the encoder on the conveyor over here. But we added some stuff with it being a legacy device. We added a pressure sensor, which is an IIoT device connecting to a hub that you can't see on the wall over there, as well as a distance sensor over here that will detect bad parts. So I'm going to turn it on, let it run. You can see it starting up. Another legacy device I'll add is the safety sensor down here. If I get too close where I need to grab the parts, it will turn off the conveyor. Step away, it turns back on. Now I'm going to put some parts down the line, and you can see how it works. Put a few more down here. Rapid fire. All right. And now I'll show you how the laser works. So if we have a bad part, and I put it down the conveyor, you'll notice it won't detect it, and it will go the whole way and light up red to show a bad part. And that's a part sorter.
So while today was just a very brief glimpse into how we define smart manufacturing and why you should care because it can have real value to your business, we want to close with letting you know that we can be of help at the Digital Foundry. At the Digital Foundry, Our mission is to focus on delivering access to digital technologies through education and training, through awareness events, and through technical assistance or de-risking with manufacturers in our region. So we can help you in taking those steps to become smarter in your operations, to implement smart manufacturing, to make better decisions. And some of the specific services that we can provide to help you get there include starting with assessing your current state, coming in and helping you to understand what are the biggest challenges and where should you start small to continue to access success and wins. We can help you with mapping your strategy and your plan through strategic road mapping processes that have been proven with other participants in industry. And we can help you with doing prototyping and de-risking of technology in our shop, where you can see how it works, understand it, understand the business value before you go out and make investments in your shop. We also offer unique workforce training to help you to upskill your staff at levels from entry level on the plant floor all the way up to your engineering staff. And we can provide coaching for your team to make sure that you're setting yourself up for success. We're here to be of service to the workforce of the future and the current, and we also are here to be an asset to local manufacturers. So take advantage of what we have to offer and some of the support that we can give you in taking this journey. Thank you for being part of our Smart Manufacturing series, and we look forward to talking to you again. Please connect with us through our website and social media.